There are 40 questions, so we are going to be solving together. I think most of you are going to be solving them. Some of them from the online classes stuff you've learned and solve exact type. For example, this question, I think we've solved something like this before. If I'm right, and if I'm not mistaken, I don't know how true is that, but I think we have. So if we've solved something like this before, we really need to waste time solving again. I don't think so. So let's try to wait for them. So well, the most important thing about this question is to know the step. So let's start. Let's see if we can get the steps. We have a compound containing 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Fine. If the molar mass of the compound is 180, find the molecular mass. Well, I think we've done a lot of questions on this. And I'll be closing this. I don't know why this thing is. It's writing something. Okay. So I think something is giving me, it's writing what I'm saying. I have to. So just, and that's what's this. Okay. Hold on, I'm with you guys. Okay. Delete. Okay, fine. I think that's good now. I think we are good to go. So about this one, like I said, the most important thing here is just to remember that the key thing, is about the key thing now. Empirical formula, you have empirical formula multiplied by n is equals to the molecular formula, the molar mass, which is 180. So everybody remember or recall how to solve empirical formula. So this is just the middle. So you have to get empirical formula. And on how to get empirical formula, it's very simple. So if we want to do that the way we do it, so you divide by the relative atomic mass. You have C, carbon, hydrogen, and I think oxygen. Fine. I think we've done exactly in the concept class. 40, 6.7, and the last one is 53.3. Without wasting time, the next thing is I said divide by the atomic mass, atomic number or atomic mass is called. This is 12. This guy is this is a 1. And this one is 16. David, please come up or meet Mike. Let's have a class. Let's have a class together. Let's show together. You are with your calculator, I believe. Let's see.
All right, sir. Good evening, sir.
So please, you are going to help me out calculate as usual.
All right.
So let's start. 40 divided by 12. 40 divided by 12.
3.33, sir.
So 6.7 is also 3.33. So the next step is I said divide by the smallest number. Divide. So by the smallest number is still 3.33. 6.7 divided by 3.33 and 3.33 divided by 3.33. So this is the method. Just keep two things in mind. Divide by the molar mass, divide by the smallest number. Then you have a empirical formula. 1, 2, 1. So CH2, then O. So come back here, CH2O. N is equals to 180 to get molecular mass. Another thing I'll talk about here is that molecular mass is equals to 2 times vapor density. So anyway, let's be fast. Carbon is 12. 12 plus hydrogen is 1. 2 here, 2 times 1, that's 2. Plus, why I'm rushing is because I believe everybody knows this. O is 16. And it's giving us 180. So this is everything here is 30. 30 N is 180. N is equals to 6. The answer to this thing is glucose. So you now come back to the empirical formula you have gotten. So it says CH2ON, and N now is now 6. So substituting that is 6, 6, H12, O6. So now that is the answer to the question, and that tallies with option C. And this guy is called glucose. Glucose. So maybe we should talk a little bit more about glucose, but glucose is an example of what? A sugar, a carbohydrate. And it's a kind of example of what they call monosaccharide. Just keep that in mind for now. Now, it's a carbohydrate and it's a monosaccharide. So that's that about the first one. I hope everybody can do that. And I hope everybody will get this. So let's move to the second question. Now, the second question is asking us about the type of bond that is found in CO2. This is also a very simple question because we are just going to focus on two things. The first thing is to know the nature of compound. Is carbon a metal or a non-metal? So very, very, very simple, like I said, because we have learned till now that what bond that exists in what? Between two metals or between metals and non-metal. It's usually what you call ionic or electrovalent bond. Ionic bond is also called electrovalent bond. Whereby bonds that exist usually between two non-metals. Non-metals and non-metals. The bond that exists between them is very simple, covalent bond. Now, then the next one is we should talk a little bit about coordinate covalent bond before we pick answer. Now the question is what are coordinate covalent? You just write. It's very simple, and you have to write what JAMB will ask you. Now, if you watch this question very well, we are looking into two non-metal. How do I know? Carbon is a non-metal because carbon is what? Is found in what? Group 4 of the periodic table. See, we have carbon and oxygen. Carbon is number 6. Oxygen is number 8. You don't need to waste time. Carbon is a non-metal because it requires 2 more electrons or 4 more to what? To complete octet. While on the other hand, this also requires 2 more to complete octet. So what a kind of what exists between carbon and oxygen to form CO2 is what we call what? A kind of sharing. So any type of bond that involves sharing, we've learned that is called what? Covalent. So the type of bond that exists here is called covalent because they are both non-metals. So that's just a simple logic. So use that logic to answer a lot of questions. When you see David, are you still there? Please come.
Yeah, I'm still here, sir.
Yeah. Now, can you please give us an example of a compound that show a kind of that's bond together and form ionic or electrovalent bond?
Compounds that form ionic or electrovalent bond.
Yeah, just give examples, just for the sake of understanding. There are lots of them. It must be a metal and a non-metal. Understand? So that's the key. I'm with you.
Okay. Yeah. NaCl, short, sir.
Very good. NaCl, NaCl, NaCl. Now, look at what the example you gave, NaCl. Now, NaCl is, Na is a metal. Cl is a non-metal. How do we know metal and non-metal? Metals are the ones that always give electrons. Non-metal are the ones that accept electrons for beginners. So you can always listen to this. Now, a very good example is NaCl, but here CO2, we just talked about this. Now, about coordinate bond, you can also keep down this short note. Now, about coordinate bond. And this short note is very important. Let me talk about coordinate bond. A coordinate bond is a special type of bond, but the important thing you need to keep in mind when it comes to coordinate bond. Now, you know, we said when we talk about electrovalence bond, we talk about transfer. One will transfer to the other. Keywords are important in chemistry. When we talk about covalent, they are not transferred, they are both sharing. Nobody is ready to leave. So that is why it exists between two non-metals. Now, when it comes to a chemical, now, a coordinate bond is a type of covalent bond, is a special type of covalent bond. So it's a covalent character too. In which one atom, only one atom, please, this is okay, a type of a covalent bond in which only one atom, please write, please. I'm using the word please. Only one atom donates a pair of electrons, not the two of them. Only one atom donates a pair of electrons to each other or to one another, whatever. Now in coordinate bond, always note that what electrons are not shared equally. Now one they give the other. You understand? Unlike covalent, in covalent they are going to be shared equally. But in coordinate covalent they are not shared equally. So now the donor atom doesn't have any access to electron. It donates. Once it has donated it, my brother, out it now. Now a common example UTM we always ask. UTM is basic. I'm sorry to say this online. They are basic in the way they set questions. That is why it's so easy to pass chemistry and physics. Because once you know the formula and you know where it is coming from, it's kind of easy. Common example you are going to see in UTM will not be more than this. Ammonia. No, ammonia is a base. Now, if you watch ammonia, it is nitrogen that is going to donate a lone pair. When they draw ammonia, they'll tell you ammonia is having a shape. The central atom is always the one that is most electronegative. Now, in this case, we have except hydrogen. So now we have N, then the other three are coming like this. You can see H, H, H. I'm not supposed to be doing this. So nitrogen is the central atom. Nitrogen is number what? Number 7 in the periodic table. So if you write number 7, nitrogen is number 7, it will be 2,5. That is very basic. Now, it goes without that this is 5. So this guy needs 3 more electrons. But the thing is what? The 3 electrons are now this. You can see it's the one that is going to what? Donate electrons. Now, it's the one that is what? That is nitrogen atom donate. It's what? Nitrogen atom, as I said, that's what they call what? Lone pair of electron. Now, this lone pair, that's why they say ammonia is a base. Maybe you don't know, you might write ammonia is a base because it has a lone pair of electron. What do they call lone pair? Now, it's simple. All these things are not hard. I guess 12. Once you write this 2,5, you can see now, if you write 5, look at it. And hydrogen, you know, hydrogen is, this one is having 3 hydrogen. Each electron of hydrogen is a star. 3, you have 3 of hydrogen, you represent it by star, star, star. And this guy is having 5. Now, if you have 5, you can do this is 5. 1, 2, 3, 4, 5. Out of these 5, a guy is going to give 3 because hydrogen needs one more to complete its duplex. No, hydrogen must be H2. Hope you understand that. So it will donate this guy, it will donate this guy, and it will donate because it is H3. So it's going to give each of these from his 5, it's going to give 1 to this one. I'm just giving you a simple way to understand this 1 to this one and 1 to this one. It's left with what? These 2. These 2 are left. And these 2 are called what? The 2 of them is called a lone pair. The word lone pair, lone means a single pair. So you are taking 2 things, it's lone pair. If you have 4 star star, 4 star star means what? 2 lone pair. Here, because it's remaining only 2, remainder 2. These 2 are called lone pair, and that is the lone pair that is always on top. Whenever you draw the structure of ammonia, ammonia is a base because it has a lone pair. So these 2 guys that is left over is a lone pair. We denote by this thing. And that is what gives shape of ammonia. And the shape of ammonia is said, please write it down. Ammonia has a shape they call, look at the shape, it's called trigonal pyramida. That is the shape of ammonia. So these are basic things JAMB will ask you. So this lone pair, what makes ammonia a base? Ammonia is a base because nitrogen gets lower. Is this lone pair that will run? Because of the presence of lone pair, that lone pair is ready to be what? To be donated. So that's why I said in reaction we call coordinate bond, only one element, one core element is going to donate electron. So this electron is going to be donated. Once it is donated, kilomarshal, what will happen is that the something will now combine as it donates lone pair of electrons through what we call hydrogen. Now you can see ammonia, most times you see ammonia NH3 combined with H plus to give you what they call ammonium. You guys know ammonia NH4 or NH4 plus. Now this ammonium now is very common. This is ammonium, NH3 is ammonia. Now this ammonia is base, ammonium is an acid. Oh my God, this thing has started lagging. Now from what I want to explain now, it is this particular lone pair that will now be donated to the extra H plus, which is a proton. You can understand? Because this proton H plus. Once it's donated this lone pair electron to the H plus, it will now form NH4 plus. So the coordinate bond is now what is as a result of what? The coordinate bond is formed between nitrogen atom and hydrogen ion. They call this H plus hydrogen ion. So most question in UTME and JAMB, whatever you call it, or even YX sometimes, is like a coordinate bond, which of the following form is an example of coordinate bond. Very simple. What will you answer? NH4 plus. Now NH4 plus, which of the following explain coordinate bond is a type of bond that is what that exists, is a type of covalent bond in which only one atom donates a pair of electrons and they are not shared equally. They are not shared equally like covalent bonds. So note that. So a very good example is ammonia plus hydrogen ion to give you ammonium. Ammonia is a base. Ammonium is an acid. Please keep that at the back of your mind. That's one. Another perfect example is the bond of more example. So if you see NH4, if you see, I've written NH4. If you see NH4 plus, think about coordinate covalent. If you see CH3O plus, this one, this guy, ozonium ion, you can see it's also coordinate covalent. This is a reaction between water and what? And whatever. This is H3O plus, ozonium. Ozonium ion, we call it. That's coordinate covalent bond. Other common example you can see around is what? Don't make mistake. In CO2, it is a covalent bond, but in CO, carbon monoxide, the most poisonous gas, CO, carbon monoxide, is what? Coordinate covalent bond. So they can also ask you that, coordinate covalent. And sometimes it is called dative. Sometimes you see it as dative bond. Dative bond. Please keep that in mind. So please note that I've given you quite some few examples out of a lot of examples, but they will test you more on ammonium and ozonium ion. So ammonium, ozonium, carbon monoxide, example of dative or coordinate covalent bond. A lot of questions will still come on that. I'm very sure about that. So let's move on. Please tell the rest. Class has started. The next one is, I think this is also basic, because we've talked about alloy of metal. Looking into this, the answer should be JJ, come up. Let's hear your voice too.
Okay, sir.
So the question is what? Let's see. You can read and let's just make it very fast. I think this is a simple question.
The constituent common to dual. Sorry. The constituent common to dualumin and alnico is. The answer is aluminium, sir. C.
Now, what is duralumin, please?
Dualumin is an alloy of aluminium, magnesium, and dualuminum, magnesium, and
Manganese is there?
Yes, manganese.
You can even add copper, but I'm not going to talk about aluminium, magnesium, manganese, copper, whatever.
And
let's make it copper, C, whatever. So that's not even, now what I want. Continuation. I don't know if you guys can hear me now. I think I'm having network issue. But I think I'm back now. So JJ, are you still there?
Yes, sir.
Now your answer is correct, no doubt, because alnico is combination of, as you can see, alnico will be a combination of aluminum, nickel, and
iron
cobalt.
cobalt.
Nickel and cobalt. So about alloys, we've talked about a lot of them. So they're asking for common. Now listen, duralumin, the major element in it is what? Aluminium. But it also contains other elements which are in traces. So if they ask you, oh, alloy of what is duralumin, the major element is aluminium. But it's good as you've known others, so it's not a big deal. So your answer is correct. I'm not going to waste time on this one because we have a comprehensive note on what major alloys that UTM is going to ask you. So let's go to the next one. So let's say, JJ, you are still here. Read this one. I'm waiting.
The drying agent suitable for drying ammonia is A, calcium chloride, B, calcium oxide, C, phosphorus oxide, D, concentrated H2SO4.
What's your answer? What do you pick as your answer?
I pick A, calcium chloride.
Calcium chloride. Calcium chloride is used to dry ammonia. Yes. Let's see if you are correct. Well, the truth about this is, we'll talk about drying agents. Listen, drying agents are also known agents called desiccants. And we have quite a lot of them in chemistry. I get it. So a very good example of the one you see around, I've given you notes on this before, is for example, we have silica gel. Silica gel. It is mostly used in silicon, but it was silicon. It's under the topic of silicon and its compound. So, and one of the things is that it is mostly used in packing electronics equipment and for food and items and stuff like that. So silica gel is one of the good drying agents you see around. It can absorb water and some other things like that. So calcium chloride. Calcium chloride, which is CaCl2, is common. H2SO4 is also common. We use, which other common, this, I want to write the common one. This one, they will write anhydrous calcium chloride most time. We use phosphorus pentoxide too. Please note that. P2O5, this thing is loaded. And this sometimes is concentrated H2SO. Now, all these drying agents, what they do is what they just absorb water. So they are desiccant, or basically we call them what? Hygroscopic substance. Another way you need to write, they also called hygroscopic compounds. Calcium oxide is also a drying agent. Calcium oxide. Now, going back to the question, because the question is technical. We are talking about how to dry ammonia. Remember, I told you ammonia is written as NH3. Watch. It is a base. Now, if you react a base with H2SO4, it's going to react with it. So that means this H2SO4 is not suitable for it. You cannot dry it with it. Now, the first thing is, how is ammonia even prepared in the laboratory? Now, ammonia is prepared in the laboratory. Just listen, laboratory preparation, lab preparation. Please write. By mixing what we call ammonium chloride, that is NH4Cl, with or ammonium salt, anyhow you want to call it. You can see it can be any ammonium salt, any of the sort of ammonium. So if it is not ammonium chloride, it can be any of the whatever. So we'll just say ammonium salt, any ammonium salt. This thing is lagging yet again. Ammonium salt. So when we say ammonium salt, that means ammonium, which is NH4, plus a salt. It can be SO4. It can be, oh my God, it's lagging seriously. It can be ammonium plus chlorine, that's ammonium chloride. So note that. Now, when ammonium salt is dissolved with what we call, now listen, you know, we want to prepare, it's very easy to know how to prepare salt. I'm talking about lab, because most questions can also ask you about industrial preparation. The way we prepare it in the industry is different. In fact, the name is called ABAP process. ABAP process. So note that that name is common. So it is the industrial preparation of ammonia. So let me use another ammonium salt so that we can write equation of reaction. I will use ammonium salt. This thing is lagging. Okay. So look at ammonium salt for the lab preparation. If I have this, for example, I'm trying to add somebody's trying to join. So we have you guys hear me? The truck is doing rubbish. Yeah, so now it will be, now from, like I said, the industrial preparation is different from what the laboratory preparation. And if you use industrial preparation, the industrial preparation is called ABAP process. That one is just direct combination. What I mean by direct combination is just by mixing nitrogen plus hydrogen. This is important. It's a reversible reaction to give you NH3. Balance up. You balance this is 2, and this will be 3. This is ABAP process. Then there will be a catalyst. This catalyst is used to speed up the rate of reaction. So please note that. Now, ammonium salt plus a base is what we use in the laboratory. Ammonium salt plus a base. Now the base can be, for example, if I use, let me use ammonium chloride, so that the reaction will be very easy for me to write for you. Now, if I use ammonium salt, ammonium chloride plus a base, let's use sodium hydroxide, example. So this is going to give us NaCl plus water plus ammonia, as you can see. So now, ammonia is prepared from ammonium salt, which was by dissolving ammonium salt in what? In a base. Whereby in the water, that is in the lab. Whereby in the industry, it is prepared by ABAP process by just direct combination at about a temperature that is higher than 500 degrees Celsius, or between 400 and 500 degrees Celsius, whatever. But there are conditions that is important now for this reaction of ABAP process to work. One is catalyst. The catalyst we use is ion, finely divided ion catalyst. Please write, a lot of questions we ask you on this. Ion must be the catalyst. It must be at high temperature. And it must also be at high pressure. These are conditions for, in fact, sometimes we say we use promoter, but for now, let's just keep out promoter from the equation. Now, my point is why I'm talking, you know, I told you revision class or mock question class are basically going to test your understanding on everything, not just the question. Now, ammonia is a special, ammonia on its own is a special compound. For example, I said ammonia is a base. Ordinarily, ammonia should not be a base, but because it has lone pair, that's why we call it a base. Now, we've talked about that. It has lone pair, so definitely it's going to have a base. It's called a base. Now, because it is a base, I'll just mute. If you can mute, let me mute you so that you just listen so that you won't be disturbing. Now, because it is a base, it cannot just be what? Be dried with what? with an acid. That's one thing. So if you look at it, I said reacting with it, what? H2SO4 is wrong. It will not dry, it will react with it. Now, when you say something is a drying agent, it must not react with it, because if it reacts with it, it will not dry it. Now, the same thing happens with phosphorus pentaoxide, P2O5. Now, for P2O5 also, P2O5 will also react with ammonia, and because it's reacting with it, it is not suitable to dry it. Now, the answer now lies between these two. Now, the same thing happens to what I want to write before. Now, if you react calcium chloride with ammonia, it is possible. Ammonia can also react with calcium chloride. So calcium chloride cannot be used to dry ammonia. So please note, I know that is why, JJ, you are very wrong. Ammonia is dried with, I think I have explained this thing to you before. David, are you there? David, unmute and let's talk.
I'm here, sir.
So David, now, I think we've talked about this before in concept class. What do we use to dry ammonia? I told you many, many times. In fact, when we are doing carbon and its compound, I told you CaO is called quicklime. Remember? David, are you there?
Yes, I'm here, sir.
CaOH, all twice, which you call calcium hydroxide, is called slake lime. Why did I take you back in time? I actually took you back lime, please, in time, because it is important for you to know that this CaOH is what they also call lime water. Remember, we say carbon 4 oxide turns lime water milky. Those are like memory verse you guys are used to in junior classes. So memory verse will help you to get 90 plus, no doubt about that, but you also need to focus on something. All options here are drying agents, but ammonia can only be dried with quicklime. And the reason is because quicklime is the only one that will not react with it. So drying agents are called desiccant because they take water away from a substance. And the most common one, as you have seen, are the one we have silica gel. And another one, which it is probably, I'm writing the one that JAMB will ask you, alkaline pyrogallo, under oxygen and its compound, we've done it. But this is the most important part of the class, nobody should miss. When we are doing revision and mock test, we are doing solution to the mock exam of this 2022 mock, 2023 mock exam. So we need to be attentive, and that's why I'm talking around it, because it may not be a direct question like this. It is something that is similar to this. Alkaline pyrogallo. This alkaline pyrogallo is used to dry oxygen. Oxygen, write it in front. You have to write note. H2SO4 is used to dry, can dry chlorine, to mention but few. CaO is used to dry calcium oxide, is used to dry ammonia, NH3. This one can be used to absorb water vapor. The same thing to silica gel, the same thing to phosphorus oxide. Water vapor from what? From component of air. Air is a mixture of gases. Nitrogen can be dried also by silica gel. Nitrogen can be dried by silica gel. Nitrogen can be dried by phosphorus oxide. Right in front of it. You write notes when you are doing revision class. I don't know if you guys are with me. So these are important things I want you guys to keep at the back of your mind. So it's very important. So another thing is nitrogen can also be dried with what we call, apart from silica gel and phosphorus pentaoxide, P2O5, nitrogen can also be dried with other elements, not necessarily, it is not necessarily silica gel or this thing. So just make sure whatever is drying anything must not react with it. So that's a very good way to keep in mind. So sometimes you won't see phosphorus pentaoxide. They will write it as heated phosphorus. Are you there? So nitrogen can be dried with heated phosphorus. When you eat phosphorus, so basically it can absorb some oxygen from water, from the vapor in the atmosphere. So keep all this in mind. So the only thing that can dry ammonia is this. It's a famous question. Ammonia is prepared in the laboratory by ammonium salt on sodium hydroxide or on what? On a base, on soluble base. Industrial preparation is called ABA process. There are other ways, but it is not necessary. Other is Oswald process. I've explained Oswald process for you before. Oswald process is basically used in preparation of HNO3, and sometimes it is what? From ammonia. Continuation from ammonia from ABA process will lead to what they call Oswald process. Oswald, OSTWALD, Oswald process. The H2SO4 is called contact process. Contact process. Contact process. Contact process. So all these processes are names Very important. So the answer to that is B. So let's keep that at the back of our mind. The next question is question 5 of 40. So question 5 is this. Now let's take another volunteer. If I call you, just come up. Our Fortune, please come up, read the questions, and let's do this together.
Good evening, sir.
Yes, good evening. Please go ahead and read the question.
Okay, sir. Which of the following reagents could be used to distinguish between classes of alkanol? I think C, sir. RBA, C.
You are contemplating. We have done alkanol and different classes of alkanol. It's there in your note. Now, this is a revision class. Let's just make it very simple so that we won't disturb ourselves. Now, for confirmatory test of alkanol, listen, just listen with me. You are with me. You are the one volunteering for this. Now, for confirmatory test of alkanol, we've done this is in your note. Test of alkanol. We use what they call Lucas reagent. Now, a Lucas reagent is a mixture of zinc chloride plus concentrated hydrochloric acid. Now, it's differentiated between the 3 classes of alkanol. That means alkanol are classified into 3: primary, secondary, and the tertiary. Now, having said that, I told you guys, alkanol basically undergo a kind of reaction which is very important. We call what? Oxidation and reduction. Keep in mind the important thing. How do you even know alkanol? Remember, you identify them by the presence of their functional group. Presence, alkanol identify the presence of their functional group. You have all these notes, but of their functional group. And the basic functional group is what? You know that ROH. OH is the functional group of alkanol. This OH that is present in them, the OH, that means the type of bond between oxygen and hydrogen. You remember, it's hydrogen bond. Hydrogen bond is a type of bond that exists between what? Hydrogen and an highly electronegative element like oxygen. For example, so the bond that alkanol show, alkanol actually show a kind of bond that is what? Called hydrogen bond. And because of that hydrogen bond, it makes it what? Very what? Soluble in water. Another important reaction. Please, you are writing like this. This is the way I want you to be writing. You're soluble in water. So, and what? Even in organic solvent. Alkanol is soluble. Its solubility is due to what? Solubility is due to hydrogen bonding. Solubility is because or is due to the presence of hydrogen bond. So at Fortune now there are 3 classes: primary, oxidation. Oxidation is addition of oxygen and removal of hydrogen. Maybe we'll write that. When you know one, I told you are going to know the other. Addition of oxygen, that's the way we define, and removal of hydrogen. So now the thing is, primary alkanol, when they oxidize, that is when you add oxygen to them, they are going to give you, I've given you this short note before, they are the one that is going to give you what they call alkana. I told you alkanals are also called aldehyde. How do you know them? Their functional group is CHO. This R means the methyl group, alkyl group. So whenever you see this R is the alkyl group, that is the non-part that is not having, they are not agile, they are not that strong. This is the major thing that takes place in the reactions. Now they form alkanas, which are called aldehyde. Now, when secondary alkanol undergo oxidation, what happened to those ones is that they form what they call alkanone. Now, the functional group of the alkanone are basically RCO. You can see CO. In fact, this is what the another name for alkanone you have them is ketones. Now, where the last one, which is tertiary alkanol, we say they cannot what? They cannot undergo any form of what? oxidation. Now, if you have known one, you know my words, my way I teach. If you have known one, you have definitely known the other. So now if I ask you, if alkanol reduce, what are they going to give? They are going to give you primary alkanol. If alkanol reduce, they are going to give you what? What type of alkanol? Secondary what? Alkanol. So oxidation is addition of oxygen, whereby reduction will be what? Removal of oxygen, and the opposite of this, addition of hydrogen. So that is the way you can always what? Keep it at the back. Now, addition, removal. There are other reaction of alkanol, alkanols, which you have in your note. For example, we've talked about esterification reaction. Please, esterification reaction, from what you know, is just reaction between alkanol and alkanoic acid to give you esters and what? And water. Now, my point here is very simple. Now, to now do a confirmatory test for all these things, are you guys there? We definitely need what? A particular reagent that can actually react with all these three types of alkanol. And what we notice is that a very good reagent we use is what? The Lucas reagent, which is a mixture of zinc chloride and concrete HCl. What it does is what? It shows that what? For example, that secondary alkanol are more reactive than primary alkanol, and that tertiary alkanol are more reactive than what? Secondary alkanol. So it will change the color of the solution of what? Of zinc chloride and what? And concrete HCl, which is formerly red before. It will change the color. Now, that is not where we are going. Just keep in mind confirmatory test. Now, another way you can test for them is what? By this oxidation and reduction. For example, I told you, if you want to oxidize, you need an oxidizing agent. If you want to reduce, you need a reducing agent that will act like what? A catalyst for the reaction to, because we told you generally, organic compounds are not that reactive. But you always need what? A particular catalyst to enhance their position or the way they are going to react. For instance, now if we want to talk about oxidation, we've talked about this now. I told you the major oxidizing agent you can think about, listen, is for this one is I gave you a lot. K2Cl2O7. I gave you Na2. Na2, please. Your mic is somehow BrO4. It's there in your notes. I gave you LiAlH4. Remember this. I don't forget things. That's one thing about me. This is a reducing agent. This is a reducing agent. This guy is an oxidizing agent. So look at what they want. Which of them could be used to distinguish between the classes of alkanol? Look at it now. We don't talk right now that primary alkanols we oxidize to give alkana. Alkana will reduce to give primary alkanol. So if you are reducing this one, if you are reducing this guy to this guy, you are going to need a reducing agent. The reducing agent is either this one, and I told you how to call this one. This guy is called lithium tetrahydroaluminate 3. I think you've seen a question that asked you to call this thing before. Yes, I remember. Yes, and this is called sodium tetraborate. It's also a reducing agent. Now, while on the other hand, K2Cl2O7 and basically KMNO4, which is very popular in your junior classes. And also, I told you we can also use what? Now, look at this. H plus means addition of hydrogen. Whereby, now, addition of hydrogen from this definition I gave you will be what? Addition of hydrogen will be what? Reduction. Yes. I said removal of hydrogen is oxidation. Addition of hydrogen is what? Reduction. And you know, K2Cl2O7 is an oxidizing agent. So definitely, we are talking about both what? Primary alkanol and what? And secondary alkanol. That means they are oxidizing and they are reducing. So this will help you know that this guy is a what? Is a primary alkanol or a secondary alkanol. Do you understand? So this is the correct answer because this is a reagent. Now, the normal answer that we differentiate without any, let me say, differentiate it unequivocally or whatever, let's leave English or English, without having any issue, would definitely be the one that we call what? Lucas reagent. But the examiner now wants to test, okay, fine, Lucas reagent is not here. Now, which other one can test this? This is what? Oxidizing and reducing it, because I cannot undergo oxidizing agent and reducing what? I cannot undergo oxidation and reduction. So let's that sink. So that's the answer to that. And please keep that. Please, for those joining the class, your note is important. We are doing solution to the mock test, and we are doing that with detailed explanations and other things you need to know. Because this will tell us exactly where or the areas where UTME are going to set their questions. And we want to make sure we understand them very well. So that means that we move to the next question and we take another volunteer. Let's take another volunteer. Ayomide, you can come up and read the questions and the options.
Good evening, sir.
Yeah, good evening. You can go ahead.
Okay. Peptide bonds are found in dash.
Options. Which options?
Okay.
And pick your answer.
Okay, sir. Option A, polypeptide. Option B, enzyme. Option C, amino acid. Option D, protein.
Okay, fine. What would you have gone for if you are in the exam or doing this? Don't waste. I will still explain just so it's just for you to just pick anything.
I'll go for amino acid.
Okay, fine. Now, before you go down, before you actually meet your mic, now, amino acid, yeah, I think you are correct. Let's see. Now, why do you go for amino acid? If I may ask you. Then again, what is the difference? Let's take it simple. What do you think is the major difference between amino acid and protein? Let me ask you that simple one.
Okay, sir.
What's the difference between amino acid and protein? Yeah, I think that should be the best thing to what I want to explain. I'm with you.
I think there's not much difference between it.
Okay, you can mute. Let me call another volunteer. Let's take another volunteer. For Lashade, you can come up.
Good evening, sir.
Yeah, what is the difference between amino acid and protein? Welcome.
I think amino acids are vitamin C, and citrus.
Yeah, vitamin C. You guys want to take me to biology level because you know I'm not a teacher of biology, but that notwithstanding, I know they are enzymes. Yes, they can act like vitamin C or whatever. Enzymes are basically catalysts, call it biocatalyst or biological catalyst. I want a good difference. Like for example, now let me tell you what I want. For example, if you say the end product of fat and oil, you say they give fatty acid and glycerol. So give me the difference between, I've given you hints now, between amino acid and protein with respect to that simple explanation. Fat and oil, now say the end product of fat and oil is fatty acid and glycerol. Are you there? Now, what's in terms of that, differentiate between amino acid and protein? This is biological a little bit, and I don't think it should give you guys problem. So what's the difference between amino acid and protein?
It's the end product of egg and.
Okay, let's make it very simple. Don't worry. Don't fret. Don't fret. Just relax. Now let's make it very simple and basic. Now I will make it very simple and basic. Now my question is, between amino acid and protein, which one is bigger? Let's make it very simple. As in, which one is bigger? Which one is a unit of another one? Is it combination of protein that will give you amino acid or combination of amino acid that will give you protein? I think it's more kind of very simple now.
The combination of.
Okay, I'm with you. Combination of.
The combination of protein will give us amino acid.
Okay, you believe combination of protein will give you amino acid? No wala. Oh, yeah, mute. Let's take another volunteer. Let's take, you can mute your mic. Nifemi, come up. Nifemi, come up here. Are you there?
Good evening, sir.
Yeah, good evening. Now, what's the difference between amino acid and protein?
Okay.
Okay.
I think amino acid is an organic compound, while protein is nitrogenous.
Why protein is what?
Nitrogenous.
Okay, nitrogenous. Yeah, not bad, is correct. Okay, I want it to be like, which of them, for example, when two amino acids combine, for example, I don't even say my answer. Let's make it like this. Which one is bigger, amino acid or protein?
Oh, protein.
Okay, protein is bigger.
No, amino acid.
Okay, combination of amino acid will give protein. Is that what you are saying? Or combination of protein will give amino acid? Which one? Somebody is making sense in the chat.
Combination of protein give amino acid.
Okay, combination of protein will give amino acid. So I think now, or you can say amino acid is the end product of protein. The end product of protein is what? Amino acid. Now, thank you. You can meet back. Now you guys are now getting where I am going. I want it to be chemistry. Now let's write this simple note. Now this topic fall under biomolecule, but I will just make it simple. All what JAMB will ask you on this. Now, when we say peptide bond, now let's write. I can just say peptide bond are formed. Simple note, peptide bonds. Peptide bonds are formed between two amino acid. Now, they exist between two amino acid. Now, especially, amino acid is said to be another point, which I think is important. Now, like somebody said in the chat, that the end product of what? Of protein, the end product of amino acid is protein. So end product of amino acid is protein. Now I said peptide bond are formed when two amino acid, when it's formed between two amino acid. Now, amino acid, for example, there's what we call bifunctional group. Now, a bifunctional group, remember I talk about amide, listen to this. I talk about amine, listen to this. And I talk about amines, and I talk about amino acids. I think this is the major thing you need to know. So it won't be too hard at all. Now, functional group, important. Amine, they are the one that have R is a key group, then you have CO, then you have NH2. We've done this before. When you say amine, they are the one that only have a key group R and the NH2. But when it comes to this guy, they are the one they say they have two functional groups. We call them bifunctional amino acid. They have, look at what they have. They have carboxylic group, COOH. Carboxylic means arachidonic acid. And they have what? The amine group. What's amine group? NH2. So write these three together. So next time you see amino acid, they are said to be what? Bifunctional. Bifunctional means then get two functional groups. Bifunctional group. Bifunctional group. They have two functional groups. So amide, and what? Amino acid. So that is under, I told you it is under, this is under what biomolecules. There are three you have to know. That is carbohydrates, proteins, and which other one? Carbohydrate, protein, and I think sugar. So all the three are called biomolecules. But note amide, and amino acid. Now, the first thing is that when we now talk about peptide bonds, now, there are two reactions that are common under biomolecule. Condensation. When you condense something, you fuse it together, and hydrolysis. Now, these two reactions is what students that are writing JAMB that they are expected to know. Like, you need to know condensation reaction and what? And hydrolysis reaction. Now, when you say peptide bond, I say it is the type of bond that is one between two amino acids, especially when the carboxylic group, when I say carboxylic group, I mean COOH group, this particular group. The carboxylic group of one amino acid reacts with what? The amino group. Now, what is amino group? Amino group means amine group. So when this group, amino contain these two functional groups. So when the two of them react together, they will now form what? A kind of bond. So amino acid contain, what I want to write before, contains two functional groups. Functional groups. Which are, we have written it there, which are carboxylic group, oh wow, somebody is writing on his phone. Now, COOH and the amine. So the next point, now, I want you guys to just understand, when these two groups react together, when they combine together, I'm making it very basic tonight. When they combine together, as in that is the carboxylic, this guy is called carboxylic. Carboxylic means arachidonic acid. It has acid and it has amine in it. So acid and amine. So that's why I call it bifunctional. Amino acid and amine. So arachidonic acid are basically called carboxylic acid. Write your note. Carboxylic acid. So when they combine, that is these two functional groups, when they combine together, now the result, you can see all these things are not high. The result is called, peptide. Peptide. Or basically they call it dipeptides because they are two. So what we are saying is that there exists the bond between this one, CO will come out and combine with NH. Then the other ones are going to attach. This is the way they will combine with NH like this. Then they will now release some amount of water. As in, when you add this one plus this one, it will now be CO, then NH. The remaining thing is what there's one H here plus the HO that is remaining. You can see I've picked CO here. I picked NH here. So if I pick CO here, this one remains HO. This one remains H. That is H2O. So this is what they are going to form when the two combine. So this, anything that is existing in this type of functional group or products is now called what? Peptides. So always keep that at the back of it. This is the way we reaction, which it is not important for you to be only to be like knowing this one, but it's just for you to see how peptides are formed. So basically, now you that you know peptide bonds, they are another thing which I think I need to write down. Peptides bond, peptide, peptides, or peptide bond, not peptides, are covalent in nature. Are covalent in nature. So they form covalent bond, are covalent in nature. So just like the type of what? Now, just like the one that what? Now, what I'm trying to explain here in a simple or in a lay, to explain to a let me explain to a non-science student is that peptide bonds are the type of bond that exist between what? All the components of what? Amine and carboxylic group. So anything that is coming together, that is fusing together, that is combination of, it's just like bringing one particular functional group to combine with another functional group to now give us what? A big change, something like that, just like your reforming. I want to explain in that language now. So bringing different functional group, especially amine group from carboxylic group, to give us CONH and what is called what? Peptides. And these peptide bonds are the major unit of what we call, they are the one that is what? That link amino acid. Now you said, we said the end product of protein is amino acid. Yeah, fine. End product of protein is amino acid or whatever. Now that means if you are looking into, listen, end product of protein, is it end product of protein that is amino acid or end product of amino acid that is protein? Please give response in the chat box. Let me see. End product of protein is amino acid or end product of amino acid is protein? Because I'm saying something now. So I'm with you so that we can pick answer. The question is combination of different peptide bonds will give you what? We give you what we call polypeptides. Peptides combined with peptides, you have dipeptide, tripeptide, polypeptide, you understand? So basically the first answer is correct because peptide bond combined with another peptide bond, it will give you polypeptide. So this one is very wrong because we are looking for the one that is not going to give us what? A peptide bond. Now going forward, enzymes. Now, how are enzymes formed? Enzymes are also biomolecules. They are present in the hemoglobin and everywhere. In the red blood cell, which is the major point of what? Hemoglobin. Now, the enzymes are a combination of different peptide bonds. Like they are a combination of CO, which we call this one, CO is not carbon monoxide here. They are called the family of, when we talk about alkana, alkanone, and whatever. So CO plus NH, when they combine together, they form different types, but they are the major unit of enzyme. So enzyme is also a combination of different peptides, different molecules of this are coming together to form a giant molecule, which we call enzymes. Protein food, whatever. Now, enzymes is also correct. It forms what? Combination of different peptides from one of this one come together to give you this. Now, this is where amino acid and what? And protein. Now, definitely something come together. Different peptide bonds come together to form what? To form what? Protein. Like a peptide bond of this one. Yes, I can see your response good. Now, a peptide bond of this one come together to what? To fuse together. Like for example, a peptide bond of amino acid come together. Then we have one particular bond come together with another one. Then we have what we call a kind of polypeptides. They come together and form what we call what? Protein. What I'm trying to say is that, for example, peptide bond is just like a long chain of amino acid. A peptide bond is just, you can write that note, I think it's better. It's just a long chain. Peptide bonds a long chain of amino acid. So when different what amino, you can see amino acid and this guy and this guy combined together, they form that. So amino acid definitely will form a peptide bond. So absolutely also wrong, because we are looking for the one that will not form it. So protein, according to what you said protein is the end product of amino acid. That means amino acid need to what? To break down into pieces. Now, when they break down into pieces, they will now form what? Protein need to break down into pieces. That means they will now form what? Amino acid. So please note that. So protein cannot be a combination of what? Different peptide bonds, because it is what? It is combination of different amino what? Polypeptide bonds that form polypeptide or dipeptide or tripeptides that is going to give you what? Amino acid. So my point is, next time you see peptide bonds, know they are what? They are majorly found in what? Amino compounds. And when you see amino compound, think about three things. Amides, think about its functional group. Amine, which is component of amino acid, and amino acid itself, which is combination of what? Two functional groups. The functional groups are very important for you to know, because next question you see, and the type of bond that exists in them is covalent. Even in protein, even in in proteins, amino acid, whatever, the bonds that exist in them are what? Covalent. So next time you see question on this, and enzymes are what? Are just a repeating unit of what? Different peptide bonds. When peptide bonds combine with what? Another peptide bonds, you are going to have either dipeptide, polypeptide, tripeptide, whatever. So polypeptide is an example of peptide bond, even from the name. Enzyme is what? Combination of different peptide bonds. Amino acid is not what? Is what? Is what we said? It's a combination. And in fact, we define peptide bonds. They are what? They are long chain of a combination of different peptide bonds ends up to give you protein, which is amino what? Which is what? Which is what? Which is the combination of different peptide bonds. So now, peptide bonds are not seen in protein, because you need to know that what? Protein is like a 3D shape, which does not have any peptide bonds in what? In it. So the answer to the question should be protein, and that is that. Let's go to the next question. We have a lot of questions to solve, but I cannot be jumping. We've done a similar question to this. When we talk about CO2 the other time, I told you the type of bond that is forward. The type of bond found in CO2 is a covalent bond. In CO is a dative bond. So don't make mistake when that's now. But this one is saying how many covalent bonds are found in CO2. We told you it's very simple. It is what? Double covalent bond. And why is it double covalent bond? Because you know that what? One carbon is reacting with what? Two of what? Oxygen. So if you draw the Lewis structure, so the answer is what? Double bond, double covalent bond. So that exists in CO2. Let's use this one to gain more time and go to the next question. Now the next question, I'll take a volunteer. I think we've done something like this also. So this time around, I'm going to take, let's take Folashade again. Folashade.
Yes.
You can read the question, I'm with you.
Which of the following ore is used for the extraction of zinc? Bauxite.
What do you pick?
I said yes.
What's the answer?
I said bauxite. Bauxite.
If you say bauxite is an ore of zinc? Check your notes now. Ore of iron.
Huh?
What is the ore of aluminium? If you say bauxite is ore of zinc, what is now the ore of aluminium? We've done all alloys and ores. Check your notes. I'm waiting. I've given you major ore that this UTME will ask you. I've given you all the ores that UTME will ask you. I told you, I've given you all different ore. And it's there in your notes. Aluminium is prepared by purification of bauxite, or by what? Deep in what? Melting cryolite. So bauxite is an ore of aluminium. Magnetite, amatite, siderite, and whatever is an ore of iron. It's there in your note. You can write that. Bauxite is an ore of aluminium. So now I'll give you second chance. The answer now will be between C and D. What will be the answer? Yes. And what are you going for? Option what? Are you sure?
Yes, sir.
Final answer?
Yes, sir.
Now you are wrong because I have also given you that what? Malachite or Malachi or whatever they call it. I use it just recall it. Yeah, it's here in your note. Malachite is an ore of copper. Check your note. I know what I've given. It's an ore.
Yes, sir. For zinc is calamine.
Yeah, calamite. God bless you. Now, yeah, calamine. And I told you the difference between calamine and calamite. Check your notes because I know you hear me very well and I told you well. So now this one is for when you hear the word all these copper spoon, copper iron, something that is made from copper. Like it is called malachite. So malachite is like copper of copper. Copper carbonate. Majorly is copper carbonate. So just little things just into that. Now then this one, spiralite, then definitely is the answer. This one is the ore of what? Of zinc. Zinc has different ore, but the common one JAMB we ask you is this spiralite. The other ore, there is zincite. Have you used zincite? Is there in your notes? Yes, you are zincite, right? So then the other one is what? Spiralite. Now, spiralite is also the one I gave you in your notes. Why you are not getting it is I call this spiralite zinc blend, zinc sulfide. Yeah, check your notes. You can see it. Abby, am I right? Zinc blend. So now, everybody knows zinc blend is all zinc. You understand? So if you say which one is an ore and I zinc blend, definitely zinc is appearing. So instead of writing zinc blend, they write it as what spiralite. So keep that at the back of your mind so that you don't give them marks. So these are other ore of what other metals. So this is zinc. It's also called zinc blend and zinc sulfide. So that's that. The answer to this is D. Don't let us waste time. Let's move on to the next one. Okay, fine. This one says laws which relate pressure and volume. We've done kinetic theory of matter. So let's take a look. Yeah. I think this one is simple.
Okay.
That is our Boyle's law. Okay. Is it Boyle's law or chance?
Pressure and volume of a gas.
Yes, Boyle's law. That's a simple question. So we don't need to waste time on all this one. I think we need to know. I don't even know why this thing is lagging. So question 10. Okay, fine. Let's take another volunteer now. An example of neutral oxide. We've done oxygen and its compound. We've done different type of oxide, ranging from amphoteric to higher oxides. So let's take some another volunteer. This time around, let me take Ayomide. I think the other time his network was bad. Ayomide, you can come up and let's.
Yes, I will, yes, sir.
So please read the question and the options and pick your answers. I'm with you.
Okay, sir. An example of neutral oxide is dash. I'll pick option C, sir.
Read the options first, please, because we are going to take them one by one.
Option A, Al2O3.
What is Al2O3? I want the chemistry name. What is Al? Then O is O3 oxide. So what is Al? And what is that Al2O3? What type of oxide is that? Like, call the name. For example, CO2 is carbon dioxide. What is Al2O3? So that's the way I want you to start all over again from the question. Thank you.
An example. Can you hear me, sir?
I am with you. We can hear you.
Okay. An example of neutral oxide is dash. Option A, aluminium oxide. Option B, nitrogen dioxide.
Okay, fine.
Option B, calcium oxide.
Is that one calcium? Calcium C.
Option D.
How can C be calcium? CO2 is calcium. I don't understand. Are you telling me CO2 is calcium oxide?
Carbon, I mean, sir. Carbon.
And what's now option D?
No, carbon, sir.
And I can hear you. Move on. Carbon dioxide, option C, and option D.
Carbon dioxide.
Option
Option
C.
D.
Uh-huh.
That'll be carbon oxide, sir.
And then option E.
Option E. Sulfur dioxide.
What do you call it?
Sulfur.
Now, sulfur dioxide or sulfur oxide, carbon dioxide or carbon oxide, nitrogen or nitrogen dioxide. It's called nitrogen what? Nitrogen oxide. Well, we've done oxygen and it's, see, I am not the kind of teacher that just come here and come and do like Bala Blue and all those guys. I don't have the time. One, apart from me not having the time, I don't take students that are not serious. I'm sorry to say that. Because I don't know, we have 22 days to exam or 21 days to exam. Somebody cannot still call elements name. It's so disgusting. I'm very serious about this. We have talked about different types of oxides, and we give example, a perfect example of each of them. Now, JAMB, whether you like it or not, we test you on oxide. Any one of them can come. I am metal oxide, non-metal oxide. And we talk about metal oxide, non-metal oxide, then they cannot be classified into different groups because sometimes if you say metallic oxide, basic oxide, non-metallic oxide, acidic oxide. Yeah, fine, you take your notes. Now, aluminum is a metal. Do you even know? That's the question. The aluminum is a metal. We've been talking activity series. We write K, N, A, C, A, M, G, A, L. What is K? What is K potassium? What is N? So like this, you still cannot call compound. It's a shame. What are you now reading? No, back to what I ask you. Now the thing is, it's better for you not to come to class because if you come to class, I am going to drag you. I'm talking to everybody now. Before you come to my class, read because I'm going to drag you. And why I'm dragging you is for you to be better. Not for you to, if I drag you and at the end of the day, ask most of my online students on SAT to find the rest. They know I will drag you. But at the end of the year, when you get 800, I will be the one that will post your results and even give you gift. That's why they do. Because if I don't drag you, won't know you don't know anything. Because I don't know what you've done, you've studied. You are still cannot pronounce aluminum oxide, nitrogen oxide, carbon dioxide, carbon monoxide, and sulfur dioxide or sulfur oxide. Sulfur and its compound, you've done it. Carbon and its compound, you've done it. Nitrogen and its compound, you've done it. Aluminum is a metal, you've done it. Aluminum is a metal, nitrogen is a non-metal, carbon is a non-metal. Then what? Sulfur is what? A non-metal. What? A non-metal. How do you know non-metal? I've said it today. Those ones that accept electrons are non-metal. Metals are the ones that give electron. Aluminum is a metal. Other metal is those ones you have in your activity series. That chart, I tell you that one is more reactive than the other. Time and time again, we are saying it. So that's your own problems. I don't think I have issues with that. But back to what you need to know. Exam is near. You need to what to just improve your study hours and things like that. Please, everybody needs to improve here. There are different types of oxides. Though metals and non-metal, we classify them: metal, metallic oxides, basic, non-metallic oxide, acidic oxide. Then we have neutral oxide, iron oxide, and amphoteric oxide. I've given examples in your notes. For those that are not there, you can talk about aluminum oxide. We've done this one many times. Aluminum oxide, zinc oxide, lead oxide, beryllium oxide. Which other one? Tin oxide. All these guys I've mentioned here are what? Amphoteric oxide. Those who don't have the short note. And the major reason why we call them amphoteric oxides is because they can behave as both as they can behaves as both acidic and basic oxide. So that's amphoteric oxide. Now, other type of oxides are what I said, acidic oxide and basic oxide. So for acidic oxide and basic oxide, I should just give you now. When you dissolve basic oxide, look at basic oxide here. Let's take a black ink. Basic oxides. They are oxides. They are basically oxides of what? Metals. Basically oxides of metal. So some oxides of metal are amphoteric because all these ones are metal, non-metal. Now, oxides of metals that they solve to form basic solution. All this one, you don't need it for now, to be honest. Like, you don't need all these short, long notes. You need a short one, very short. The perfect examples are magnesium oxide. Magnesium is a metal, you know. Calcium oxide, CaO. Calcium is a metal, you know. To mention sodium oxide, NaO. So these are examples of what basic oxide. The other type of oxide is acidic oxide. Permit me to quickly change the light. Acidic oxide, for acidic oxide, they are the one that were dissolved in water to give what? To give acidic solution. They are basically oxides of non-metal. So you have example, non-metal, you know, carbon dioxide, CO2 is acidic because carbon is a non-metal. SO2, like your sulfur is a non-metal, the same thing. Nitrogen, NO2. So that's how you know them. This is a simple topic you should know. Then coming to the last aspect, which I want you guys to know, which is the one here, neutral oxide. Now, example of neutral oxide, when I say something is neutral, you know, there's a common thing in physics and except in chemistry that we do, and that is talking about litmus paper and test. When a particular reagent is neutral to litmus, does not react to litmus, you said those type of oxides are what are neutral. Very simple. A perfect example is carbon monoxide. The answer he picked is correct, but it's not about the answer because your own question might not be which of the following is a neutral. Your own might be which of the following is an example of higher oxide. Then why can't you study all the oxide? I know that this question is definitely coming out in UTME. Then let's know that one because all these options are going to be talked. We talk about each of the options. And that is the essence of playing for class or whatever you guys are doing. So you have to take it and write notes, please. Listen to the word please again. Now, back to what I'm saying about neutral oxide and example. Now, when you say something is neutral, basically when something is neutral, you said it does not have any effect on pH. Now, when something does not have any effect on pH, you said it is neutral. So, but in chemistry, when you say neutral oxide, they are just oxide. They are not what you define them in terms of, you know, acidic and basic. Because I've been talking about a basic oxide, oxide of metal, acidic oxide. Now, so that means neutral oxide, they are what neither acidic. You understand? But nobody will ask you to define in JAMB or basic. So oxide that are neither acidic or basic. But what you need to know is what me and you know that we need to know the example because the example is what we carry money. Carbon monoxide, the one we have here, CO. Other example apart from carbon monoxide is water. Water is everything I want to write here are neutral to litmus. They are not acidic. They are only something is neutral to litmus. You know, a litmus or to pH rather. pH is a scale that graduates between a 0 and 14. If English is 2, if my English are too high, let me simplify that as if I'm taking a kindergarten student. I can do it. That's why people prefer me to teach them things because I can break it down to any level. Now, it's just a scale. The scale comprises of what? Numbers that range from 1 to 14. So if we say it range from 1 to 14, that means it shows acidic character and basic character and neutrality. When numbers fall between 1 to 6, we say what? When you measure pH of any compound and it's from between 1 to 6, you say that stuff is acidic. They will not write down. And they don't know it. How will you think? It's a shame. Because they are basic things. Now, and when it moves from what? When it's at 7, you measure an organic compound or inorganic compound or any element or whatever, and it's giving you a 7 scale on a pH. It says what? It is the one we call neutral. Next question can ask you, what is the range of scale on the pH scale? Somebody will still miss it. That's foolishness, to be honest. So all these things piss me out. That's one thing about me. I've given notes, I'm giving it again. So N2O, the nitrogen oxide, we've talked about this one. This is what it is called laughing gas. It's an example of neutral gas because it has no effect on litmus. It is neutral to what? To litmus, it's neutral to pH and all stuff like that. So next question asks you, which of the following is neutral to pH? CO, water. Water is not acidic, neither is it basic. Please find somewhere to stay, please. Then the next one, we have other example. We have NO, nitrogen oxide. Is also, this is not no, this is nitrogen oxide. This is dinitrogen 1 oxide. I'm calling the names now so that you can write them down. And you study them. It's not just writing. Write them and study. I'm talking to everybody. Write and study. Exam is near. Then other ones, if you still want me to write, is the one now. The question is sometime. Carbon dioxide, because I know JAMB very well from experience. Carbon dioxide is an acidic oxide, but carbon dioxide sometimes can also behave like a neutral oxide. You can write that. I'm giving you exception, which is what is important. So in some option, they will just be this, and this. It doesn't pick neutral oxide. So, but the answer the teacher told me in class is not there. So I'm saying that carbon dioxide is technically an acidic oxide, but it can also behave as a neutral oxide under certain conditions. So write that, because exceptions are what make question tough. So that's that about that. That's not where we are going to go. So the answer he picked is correct. Thank you very much for telling us the right answer. We appreciate it. Let's move on. The next question. Question next. I think this one is a basic question. We don't need to waste time on this. Which of the following is the purest form of water? Everybody knows. And if you don't know, you can go and check. This is the answer to the purest form of water. Rainwater is the purest form of water. And the reason why rainwater is the purest form of water, can anybody tell us why rainwater is classified as the purest form of water? Anybody? I'm waiting, you can just understand. Volunteer and talk. Why is rainwater called the purest form of water?
Water from the nature.
Is that what? I can't hear you.
Because water from nature, sorry.
When you say something is pure, what are you saying? That means it doesn't have what? Impurity. I actually expect you to just say it doesn't have impurity. It doesn't dissolve in any mineral. As, for example, it's free from all those salts, whatever, and you don't get any pollutant. Understand? Then it has pH. The pH is neutral. It has neutral. It is neutral to pH, just like neutral oxide we talked about. So it doesn't have any impurities, and it's one of the purest forms of water. You can note that. Now the next question, we don't need to waste time. The next one here is this one says the most polluted. This one is also a continuation of the type of question we just answered. I'm talking about this. The correct answer to this is underground water, because it contains a lot of what impurities, oil spillage and something like that. So I don't think we need to. Now, underground water will be more polluted than what? Than ocean water. Do you know the reason? Water from underground, because underground there are a lot of what? The fabrics, or what you say, decayed organic matter. Do you get that underground? So we don't need to waste time on. I think that one is more like social study or basic science. The next one is let's take a volunteer for this, so that you don't just slip on bike. Let's take Fortune to help us with this one. Read the question and option, and let's see.
Okay, sir. Hydrolysis of organic nitriles will yield what? A, amides. B, ammonium salt. C, ethane nitrile. D, ammonium ethanoate. I think the answer is list of organic. I think the answer will be amides.
Okay, we talk about amides. The thing is, let's start to begin with. Let's talk about what are nitrites. That is your answer are correct. Your answer is correct, because I just talk about, when I talk about, another name, when we talk about biomolecule. Now, when we say nitrites are also called cyano. So next time you see them, it is a combination of carbon with triple bond and nitrogen. Please, everybody should write, very important. So carbon with triple bond and nitrogen. So it's under the compound. You can see when you see nitrogen and carbon, you should be thinking of, okay, when they say hydrolysis now, that means you are adding water to it. So if cyano is also called nitrite, this is cyano, organocyano. This cyano are also known as nitrite. So that means they contain carbon and nitrogen. So when you now add water to carbon and nitrogen, that is, you want to hydrolyze it. What to? Those questions are, even if you don't have idea, your answer is correct, like I said. Now, when you now add water to it, hydrolysis of this is that when you eat it in the presence of acid, example, hydrolysis is what? Adding of water in the presence of acid. There will be some acid. The major acid we use is H2SO for HCl. So now, you know, I'm reacting water with Cl, whatever. So what you see now is that I am going to produce, I will just write this is what I call carboxylic acid the other time, if you remember. And this is carboxylic acid, and amide. Now the amide will now come. The amide, remember I told you, amide is written as RCO. I'm only writing their functional group. CONH2. Amide is CONH2. Amine is ordinary NH2. Amino acid is COOH and what? NH2. Don't make mistake. So what I'm saying is that when a cyano, which is also called nitrite, that is RCN, which is a cyano, reacts with water, then a kind of protonation reaction will occur. It will give us RCONH2. This is what you are going to form first. And this guy, this is the functional group of what? Amide. Students should write. So, but the reaction does not stop there. So that this guy, RONH2, which is amide, can also react with what? Further water plus hydrogen, H plus or whatever. That give you the final product we call COOH, which you know as carboxylic acid or acrylic acid, then what? Ammonia. Please note that there is protonation of H plus. H plus is always present there, or hydrochloric acid or H2SO4, whatever. So the question is, when you hydrolyze nitrite, the thing is you need to know nitrite. Nitrite basically are just what's also called organic cyano. That's their functional group. They are called cyanide, or sometimes they are called alkyl cyanide. So please, they are used as organic solvent. So they are sometimes they are usually used as organic solvent. So that's cyanide, cyano, or nitrite. So when you hydrolyze means you add water to it, it's going to give you amide. You are very, very correct. So now it gives amide. Hydrolysis of it what? Give amide. Now, and again, you can see why this question is kind of very dangerous. Now, when it gives amide, later it's what? It gives what? Organic, what called arachidonic acid or carboxylic acid. And what's this one? Is this thing else what? What's this one? Is this not ammonia? So it can give what? Hydrolysis are explained in two ways. So note that acidic hydrolysis will give you, this is the one acidic hydrolysis because I'm adding H plus. It can also undergo another type of hydrolysis that is basic hydrolysis. When it will not be H plus, that will be up here. It will be another thing. And that one will definitely give you, it's the same thing. Look at when it is basic hydrolysis. I call this one acidic hydrolysis. Addition of H plus or xenon ion is called acidic. That's why I said in the presence of HCl or H2SO4. So acidic hydrolysis. Sometimes it can also undergo basic hydrolysis. Let's say basic or alkaline. It's form notes. It's more or less of the same thing, but in this time, you can see cyanide is RCN plus it's reacting with this OH from what? Base. Base is OH. Acid is H plus. In this case, it's going to give you, you can see RCONH. Because one of the H here, I'm getting it as come back here to come and form what? Basic, alkaline. So then continuation will now be RCONH. You don't need all these too much. Just put the final plus what? It will now dissolve in water, which is the hydrolysis. Then it will now give you RCOO plus NH3. Now, some question can be dangerous. And that is why I'm talking about this basic hydrolysis. Now, in what? Just remove hydrogen from what? From what? Acidic hydrolysis. The final product of basic hydrolysis we call. So when you remove hydrogen from this one is arachidonic acid and ammonium salt. This one is now CO. Which functional group has CO? No. Remember, the functional group that has CO, remember, is what? Alkanoate, which is called esters. Please form your notes and read them. So remember, remove H plus from ammonium. It will give you ammonia. So now look at this question. Hydrolysis of organic nitrite yields, now it yields amine. Correct answer. Now look at the ammonium salt. Now it yields ammonium, not ammonium salt. So that is why this one, because some of you might think ammonium, don't be ammonium with this. Now ethane nitrite, it yields here. Look at it, it yields nitrite. What is nitrite? Nitrite is CN. So it doesn't give you ethane nitrite. It yields what? Amines. Final product is now what? Carboxylic acid, so it is acidic hydrolysis and what? Ammonium. Now, whereas if it is the other way than basic, remove H from these two answers. Remove one H away from all the three answers. That is yielding. So that you don't, then ammonium methanoate is wrong. It does not give ammonium methanoate. So the correct answer is what? It yields what? It yields organic acid, arachidonic acid or carboxylic acid and ammonium. Also what? Amine. So out of all the answers here, the correct answer, the one we have that is only repeating itself is amine. So you can see next your own answer in the list of answers, amine may not be there. You can see what? Organic carboxylic acid or arachidonic acid, or you may not even see, you can just see ammonium, not ammonium salt. Ammonium, please note that. And if it is a basic, you will see what? You can see arachidonic or esters, or you see ammonia, or you see what? This one is what? This one is also amine. But this one now, because you look at the amount of CH attached to it. So this is like primary amine. Differentiate the functional group of amine, and amino acid. Please don't make mistake. These are very, very important. So that's that. The correct answer is A. So let's take this 10 minutes to the end of the class. Let's make it 20 questions. This 13. So let's move on to the next one. David, you can come up and take this question. Read the question and let's.
Good evening, sir.
Yeah, move on. I'm with you.
All right, sir. A base used in the manufacturing of toothpaste is.
Yeah, move on.
Okay. Option A, sir, hydrogen peroxide. Option B, calcium carbonate. Option C, fluorocarbon. Then option D, siarcase.
Okay, I think there's an error in the last start. What's the answer? I think we've done it before. What's the answer?
Option B, sir, calcium carbonate.
Calcium carbonate. Okay, fine, you can mix back. Calcium carbonate is used in manufacturing of toothpaste. It is not the only thing that is used in manufacturing of toothpaste. If this one was what they call xylitol, I think it's a spelling error. It could have also been the answer because this is also present in what? In toothpaste. So there are lots of compounds that are used in making toothpaste. Maybe we'll talk about them for your own question. You don't know what might come, and because you don't know, let's talk about other things. Now, calcium carbonate, which is the right answer here according to the spelling. Calcium carbonate is used because it is used to remove stains from teeth. When you have stains from your teeth, you use calcium carbonate to remove it. So it is a mild. It is a mild abrasive substance and removes what? Stains from what? And the other product is what? Which your own might contain. I'm very sure about this one. It's what we call sodium carbonate or sodium bicarbonate. Sodium carbonate or sodium bicarbonate is also used in making of toothpaste. I think it's important you know this. This is sodium bicarbonate is also called baking soda because I know them very well. Baking soda. So this one is also a kind of abrasive, mild abrasive. It's also used in what? Whitening of the teeth. Whitening. I don't know how to spell whitening. is it whiten, to whiten the teeth? Write the correct spell. I don't know how to spell. Now, whiten the teeth, and sometimes it's given fresh breath. You know, that's close up, right? For fresh breath, a bit. You can see when they're doing it, they always use somebody with white teeth. So sodium carbonate is one of the most. Sodium carbonate, calcium carbonate, keep that in. Then sometimes there are some stubborn stain in your teeth. So when there's stubborn stain, we use silica. Silica. So to remove this one, also remove stubborn stain. So there are also other things which I think is common, like sodium fluoride. Now, you know, fluorine. Fluorine, you guys know fluorine. Sodium fluoride. So sodium fluoride. So options might not carry this one. Sodium fluoride has NAF. So sodium fluoride is common in all toothpaste, and it's because it's removed tooth decay. So this one takes you to the topic of halogen and compound. Now fluorine. Now fluorine from fluoride, in case you don't know. Fluorine removes tooth decay. Write it down because you can reconstruct it. Fluorine. That one kills germs. Bromine. Bromine, iodine. That is goiter. You know goiter, you guys, you know goiter. I think everybody is a biology student. So goiter, kills goiter. Bromine is for majorly, bromines are majorly used for this thing is not moving again. I can't move now. No. Bromine is majorly used for clean. I think it's also used because I know fluorine would kill the care. Goiter is for iodine test. Fluorine kills germs. This one took decay. Bromine, it will come. It's not coming now. I don't know. Then I want to go about xylitol. I told you I was thinking this one was xylitol before because xylitol is also used in making toothpaste. Now, xylitol is a special thing. That is that thing that you know, most of you when you are small, even now, some of you still leak toothpaste in your house. You leak toothpaste. Yes. Yes. Now, it is the thing that adds sweetness. Sweetness. This thing with the move now. I'm going to write. Yeah. Now, this is bromine. I said bromine. Bromine in my head. So, move. So this is a sweetener in what? Toothpaste. Please write it. Don't waste time asking. You know, questions are random. That's why we want you to come to this class and be part of it. It is called xylitol, not Ziaclis or whatever, xylitol. So it might be. That is what we're going to say. Now, I'm talking about bromine. That one is not coming. Under treatment of town water, fluorine is to kill tooth decay. Chlorine is to kill germs. Iodine is for goiter. Bromine is for what is not coming. I don't know why it's not coming. Yeah, I don't know. So anybody that have a idea, trying to recall, you know that thing very well. Sometimes it happens like that. You can tell me in the back and chat board. I know it's all these things fall under sedimentation and treating town water. It's also to kill infection. I just know, just like chlorine. So it's more or less to kill infection too. It's not that. So, but these three fluorines to decay, that is why sodium fluoride, you know, sodium fluoride contains fluorine. So I just want to let you know, it's also to kill infection, just like not to kill some infections in the water. So note that. So that's that. Iodine is, you know, goiter. They will ask you that one. You cannot run away from goiter. Goiter questions. Iodine, they kill goiter. It's with this. This thing is just rubbish. So this is 3 minutes to the end of your class. But you still have 15 questions. Now, this is a question on which of the following listed below will exhibit the most electronegativity. I have told you time without numbers. How do you know the one with the most electronegative is what? By starting from the last group of your period. That is it. Then you come from that side like that. So because electronegativity, this thing is not moving. Electronegativity increases across the period. Electronegativity. Increases across. I mean, how do you guys spell across? Whoop? The period and decreases down the group. This is a statement that is important for the JAMB. So if that is the case, and I've given you the common one, F, O, N, C, F, O, N, C, S, C, H. Maybe that is good. Fluorine is the most electronegative element. That's another statement you can write. Fluorine is the most electronegative element, except apart from the noble gases. So they move because noble gases are not reacting. They increase across the period. Periods are what? Periods are not your vertical, they are not your horizontal. So they are not, you know, we have group 1, vertical line at group 1, group 2, group 3. You can see my mouse, group 4, thing is hanging, 5, 6, 7, 8. Then period 1, period 2, period 3, period 4. So if you move from left, that is from this point to the right, like this, across the period, like you are moving from left to right in the periodic table, from left to right. As you are moving from left to right, that means you are moving from group 1 to group what? To group 8. You understand? So as you are moving from left to right, you are increasing electronegativity. So that is why we say it's increased like this, from left side to the right side. So it goes to that way that if I can predict the group of all these things, I'll be able to know the right answer. Because I know as I'm moving from 1 to 2, 3, 4. So basically, aluminium is in group 3. How do I know? Aluminium is a metal. It is number 13. Right? Aluminium atomic number is 13. So sometimes question can ask you all these things. So number 13 is 2H3. To know the group of this thing, you can easily use the old school configuration. Group 3. Silicon is number what? Number what is silicon in the periodic table? Neon, sodium, magnesium, aluminum, 13. Silicon is 14. So that is our 2H4. This thing is standing. For some of you, I don't want to abuse you. I'm busy pressing phone when I'm busy trying to make sure you understand things. This is 2H4. And it goes without saying that this is number group 4. Group 14, or you say group 4 in the old periodic table. So if someone asks you to compare the two, definitely this guy will be more electronegative. I think just take them back. And if it's the case, you guys are back, we soon finish his 10. It's 10 already. So like I was saying, it goes that this guy will be more electronegative than this, because as you move from left to right, across the period, electronegativity definitely is going to increase. So now we go into the next one. I think the next one is phosphorus. So if you check out phosphorus, phosphorus is the next one after aluminum, silicon, phosphorus, sulfur. I love this. Now, check out phosphorus. Phosphorus is number 15, P15, 2H5, group 5, or group 15 of the modern periodic table. Then sulfur, group 16, 2H6. So the ball is in your court. Which one is my electronegativity? Drop your answer in the comment section. For my explanation. Drop answers in the comment section. Which one is more electronegative? I've explained, and I think it's very simple to do. Yes, I'm waiting for other response. I can also only see few. Yes. Other response. I'm waiting for those that are yet to drop their response. Okay, I think we have all options now. Okay, fine. I'm seeing some people are picking C and some people are picking D. So we need to just, okay, phosphorus, sulfur, phosphorus, sulfur, phosphorus. So phosphorus, sulfur. Now the thing is, let's take it to understanding level by bringing a periodic table and showing you something. You know, chemistry is full of exceptions, and why it is this and it is not that. I will explain to you. That's true. Now, why is it phosphorus for this phosphorus? Why are you guys not going for sulfur? Yes, I need response. Anybody can unmute and talk to me. I want to run this class, please. I have to do some other things. You know, I'm a kind of multifarious teacher. I do a lot of things. Yeah, I'm telling you, my own answer is sulfur. From my explanation, I say as you move from left to right, electronegativity increases. Electronegativity is the ability to attract electron towards itself, the ability to form covalent bond. Now, when a substance has high electronegativity, well, it has the ability to attract electron towards itself in a covalent bond. It forms more covalent bond than electrovalent bond. Now, listen to this. Listen to this. Now, in fact, electronegativity value, there's a table of chart for it. For sulfur is about 2.58. For sulfur is 2.58. Whereby I can send you a electronegativity. I have that chart. All those things are what I used to teach all these A levels. It's 2.19. So sulfur has this. Why phosphorus has this? Now, so that is according to Pauli's scale. So the truth about this is what? Sulfur will form more covalent bond than what? Than phosphorus. So your online has actually failed you today. Those of you that you Google answer. So now, when you are moving from left to right, in fact, I told you, look at what I have in terms of order, the common one. See, fluorine is number one, followed by oxygen, followed by nitrogen, followed by sulfur, followed by carbon, followed by hydrogen. So you are still comparing sulfur now your mate. Can't you see? So please, let's wise up. I'm doing it up to 20, remain 5 more. Number 16. A metal that is amphoteric, we've done, thank God, I don't need to waste time. I listed an example of amphoteric the other time. Now, your Google will still give you this one, I'm very sure. Because you guys are picking answer from your, what's it called? From Google and all these rubbish answer. Or AI that is misleading you. I've given you an example of amphoteric oxide the other time, and I've given short note of that on that. I don't need to waste time. Tin, lead, tin oxide, lead oxide, aluminum oxide, beryllium oxide, and which other one? Any other one, you have it. You have it with you. The next one. So, David, what's the answer to this one? I'm waiting. Don't Google anything.
Option A, sir.
So explain. Can you explain? What's washing soda yourself to begin with?
Sir?
What is washing soda? What's washing soda? Now, I talked about baking powder the other time. What's washing soda? We talked about washing soda and sodium carbonate that is used to remove permanent hardness of water. Because you better don't sleep on bike. I will always talk my own though. So that's washing soda. Are you there? Please, I have to, if I want to make sure this thing is
Yes, sir.
So that's washing soda. It is used to remove permanent hardness. Remember that. That is one of the key important. I think I am back. You guys hear me now? David, can you hear me? Can you hear me?
Yeah.
So I'm saying washing soda is Na2CO3. It is used in treatment of and to remove permanent hardness of water. Washing soda. In fact, if it contains water of crystallization up to 10 mole. Now, that's not what we're talking about. Now, one thing about washing soda, in fact, washing soda basically in chemistry is said to be, they call it has a particular chemical name they call it. They call it alkaline attack. Like the way you call Benzema a good attacker, you call Suarez and the rest, Messi and Ronaldo. Now, you call what Na2CO3 as what alkaline attack. So because it's what it reacts with alkaline, especially when it's combined with aluminum. Now I said Na2CO3. Let's explain with reaction. I think it's the best way to understand. React with aluminum. You know, it's going to contain some water of crystallization, I told you. That's H2O. Then it will give us, it will form a coating layer like sodium NaAlOH4. Then it will liberate hydrogen gas. Now, if you watch this, Na2CO3 here, I don't know if I'm, yeah, I should be audible. Continuation says, from this reaction, you can see that from this reaction, you can actually see that here, Na2CO3 here, removal of oxygen is reduction. Addition of oxygen is oxidation. Look at this guy, it was Na2O3. This guy now has what? Look at this, Al here, this is H2O. Now we want to look at what happened to Na2CO3 in this reaction. Has it oxidized? Has it reduced? So the work of this one, you can see that Al was Al before, but at the end of the day, oxygen was combined with it. So this Al has been oxidized because it is, and oxygen was added to it to give us NaAlO4, which you can see. So that is aluminum hydroxide. So this aluminum hydroxide, as you can see, so this aluminum hydroxide, we now sometimes we dissolve with time. You know, we are forming aluminum hydroxide or sodium aluminum hydroxide plus hydrogen. So these two compounds that is formed is kind of, let me say, it's showing us that what sodium carbonate can dissolve aluminum to give us aluminum hydroxide and hydrogen, or sodium aluminate and nitrogen. My network is very, very bad. So now, most time, this is a perfect example, most time, that chemistry teacher will tell you that it is not always advisable to use washing soda on what? On aluminum, because this particular layer, this is like a layer or a protective layer that is going to be formed on what? On hydrogen. And with time, this protective layer, this thing will react with each other. When they start to react with each other, it will now make this thing to be what? This aluminum something to corrode. So what I'm trying to say is very simple, in simple language is because something is yielding hydrogen gas. You can see aluminum has been oxidized. This guy has what? It has reduced. Sodium carbonate has what? Has reduced because it has sodium carbonate before then. The oxygen was what? Transported to aluminum. Oxygen has been removed, that's reduction. Removal of oxygen is reduction. So washing soda dissolve aluminum by reduction is correct. And they are going to form a protective layer. At the end of the day, it will now work. Instead of it to be coating it, it will combine with hydrogen at its form, and then we see what they are going to be saying rusting. with time it will rust or what? Reduce its potency, its power. So the answer is correct because NH4CO3 is oxygen is releasing to aluminum, so NH4CO3 is reducing. So the answer to the question is what you know that dissolve aluminum? It's dissolve aluminum utensils by what? It is going to what? Reduce it. It is not always advisable to use it because, like I said, it will corrode it. It will dissolve. Aluminum will dissolve and corrode with time. So, and this is what is going to form with time. But aluminum sometimes reacts with this thing to give us this. And this thing with what is the corrosion we are talking about. So that's that. The answer you picked is correct. So I will take the last 3 questions on my own because of time. Now, this is a perfect question of what we've done on that metal and its compound. Ferromagnetism are compounds of nickel, iron, and cobalt. So ferromagnetic substance contains, done it in physics to nickel, iron, and cobalt. So we have ferromagnetic substance are the combination of nickel, iron, and cobalt. This is the 3 compound that is used to make ferromagnetic substance. So the answer to this is no, or nickel. So the next one, 19. Now, I think we've done this. Foams, that is, I have to talk about this. Let's check 20. Okay, true solution can be classified into dash. Now, solutions, I think we've also talked about this, are classified into 2, true and false. True solutions are called, they are formed by homogeneous mixture. Please form note. And these are formed by heterogeneous mixture. Heterogeneous mixture. True solutions are called solution, basically. And false solutions are called colloids. Please note that. Now, there is another type of solution we call suspension. A suspension is a type of solute that forms a semi-permeable layer when a solute is dissolved in a solvent. For example, I told you calcium sulfate form a suspension. So because they are kind of what they have a kind of bigger solutes that all the solutes, which is a solid, will not dissolve in the liquid, which is a solvent. When this occur, we say it's dissolved, but it's not everything like solvent. We say it is forming suspension. That's suspension. Colloids are different. When we define colloids, we don't use solute. Solution basically, which is true solution, is solute plus solvent. Whereby colloids are not solute plus solvent. For colloid, the solute is called the disperse phase, is the solute. Whereby the solvent is called the disperse medium. I need to talk more about this, but because I'm rushing and because of my time, disperse phase is the solute for colloid. There are 13 examples of solute, according to the scientists called Tyndall. In fact, he gave what they call Tyndall effect. Tyndall effect. That effect explains the relationship between what different types, the 13 example of what? Of colloids. A very good example is emulsions, that is here. Now, a true solution is what? A solution. A true solution is not a colloid. So here I can tell you that none of the answer is correct. A colloid is an example of emulsion or emulsion. Emulsion is a solution about whereby a solid or a liquid dispersed in the liquid. When we talk about state of matter to explain solution, instead of talking about solute and solvent, we are talking about colloids. The dispersed phase in what? In emulsion place is what? Liquid dispersed in liquid. A liquid substance dispersed in a liquid substance. That's emulsion. It's an example of what? Of a colloids. So true solution can be classified into what? Solution and colloids. The answer to this question, they're talking about classification. So solution are classified into what? Solution and colloid. So answer is colloid, no doubt about that. And there is an example of colloid. Now, what he used to differentiate between a colloid and a solution was that a solution, which is called true solution, is going to what? We obey what you call rectilinear propagation of light in physics. When light is shown to a true solution, they pass what? Light pass on a straight line when light is shown to them. While on the other hand, colloids are going to what? They are going to scattered a ray of light. So the ability or the tendency to scatter ray of light is called Tyndall effect. Next question you can ask you on this. I hope you are getting this. So that's question 20. I jumped question 19 because I want to explain better. Now, foam is also an example of color. When you want to explain colors, you talk about solid, liquid, gas, dispersed phase, and dispersed medium. Now, when you talk about foam is an example. I talked about a lot of 13 examples, but you only need to know 6 for JAMB. JAMB is so simple and basic. Apologies about with all due respect to JAMB and the coordinators, but it's not that it is basic. It's just like they want to test you on simple things, application of them. So please note that. So now, how can we explain form? We can explain forms also in terms of dispersed phase and dispersed medium. So the dispersed phase now, we use state of matter to explain colors. Now let me take it from the first one, salts and gels. Now, for salts and gels, that's right. For salts is number 1, and gels, I'll take them together. Gels use them very well. Yeah, this is a first example of colors. The liquid, the dispersed phase is the what? A solid material. Salts are solid material. They disperse in what? In liquids. So the dispersed phase is the solid. The dispersed medium is the liquid. Are you guys hearing that? So solid is the what? Is like the solute, but we don't call them solute. We call it the dispersed phase, liquids. So salts and gel. Now, I talk about emulsion. This one should be separated. Salts, gel, emulsion. Emulsions is another example of colloids in which it can be solids or liquids as this dispersed phase, dispersing in a liquid or passing. This is something dispersed, is passing. Then aerosols. Those are your spray can. When you open mud, when you open all this thing inside thing, gas will come out. You understand? So now let's explain them. Now, if you say aerosols now, what is dispersing in what? Then smoke is another example. I'll give you the basic one. Smoke. Now, when we want to talk about aerosols, I said the spray can. Now, look at spray can. Let's take a bottle of a cup of not a cup of dilap, a bottle of malt. Let's take it for example now. When you open it, what will happen? Gas will what? Gas will pass out. What is inside that thing? Liquid. And when liquid is what? Is released to air, what happens? Something comes out. Gas. Now look at the case of smoke. It's simple. You have to burn firewood. It is firewood that is what? That is bringing out what? Smoke. So in case of smoke, when you look at smoke, it is what? It is a solid substance that is dispersing in gas. I don't know if I'm communicating. It's a solid substance that is dispersing in gas. Thereby, in case of is a solid, dispersed medium is gas. But in case of this guy, it is gaseous substance that is dispersing in what? In liquid. So those are the differences you need to keep in mind. So then to the question. Everybody know how foam is being formed. Foams. All these foams are not films. There's not between films and foams. So now looking at how foam is being formed. Now, foam is a very good example of what I just explained now. Look at foams. You know foams very well. Those, can I define, can I disperse that? Can I talk about that? It's an example of aerosols in which, because if you look at foams, foam is like, I want to use something called, like a fog. You know fog? Yes, fog. Yes, I think this is a good example. Now, fog. Because there are other, it's not necessarily like a fog, because in fog is liquid dispersed. Let me look at, okay, it's like a bubble. Yeah, I think it's good in that way. Let me use bubble. I want you guys to get all this. So this is my last question. I've done 20 questions I want to do. Even 20 will be done tomorrow. If you don't have class, my biology class tomorrow, I'll take the only 20 questions. So look at this, guys. I said foam is an example of bubbles. If you watch football and you watch West Ham United, they just been banter tonight. They were beaten 5-1 by Newcastle. If you go to London Stadium, they call their stadium for guys online, you are going to see that what they always blow bubbles. Now, bubbles is a very good example of a foam. So in this type of situation, is a perfect example of aerosols because it's a situation that explains a gas that is being dispersed in liquid. Gas moving inside liquid. That's what we are talking about. So aerosols is an example of colloids. So an example of aerosols is what is foams. Now let's talk about another example I didn't talk about. Smoke is different. Now milk, because I can give other example. Your own can be milk. Now milk is an example of what? What type of colloid? What state of matter I'm moving into? Liquid, just like emulsion. Liquids disperse in liquid. Liquid. You know milk. Now liquid and liquid. Water and what? Liquid and liquid. Another one I want to talk about as an example is fog. The other time, I was talking about fog because they will ask you fog too. In fog is kind of different. In fog, it is a liquid that is dispersed in gas. Fog. Liquid dispersed in gas. So you need to know these ones for you to be what? Perfect. Now, let's note this now. These are common examples. So the question we have before us is very, very simple. So drop your answers in the comments box. What will you pick now as an answer? Let me see. Drop your answers, please. I want to learn this class. Let me say I end 10:30. I'm waiting. Yeah, please drop your answer. Don't run away. Like I said, I have to finish it. Okay. Solids and aerosols. A smoke is an example of aerosols. So this one also should be apologies. Smoke is an example of aerosols. That's a mistake. Oh, I'm supposed to print this. Smoke is a very good example of aerosols. Okay. Okay, aerosols. We have aerosols basically can be either, when we do it is liquid, dispersed in gas. So don't let us make mistake. Aerosols basically are classified, can be solid aerosols or liquid aerosols. So if it is solid aerosol, it will be solid dispersed in gas. If it is liquid aerosols, it will be liquid dispersed in gas. So, but majorly, aerosols are liquid dispersing in gas. So in this type of situations that we have, foam is an example of what? Now you've dropped your answer. So foam is an example of, let me see, option D, yes. Option D, because we just said foam is a perfect example of a situation whereby a bubble. And when we talk about a bubble, we are talking about a situation whereby a gas is being dispersed in what? In a liquid. So now, out of all these options, to be honest, in all sincerity, gas dispersed in liquid is a very good example of foams. And not any of these options is correct, to be honest, because there is no one in which a gas is dispersed in liquid. So it's a combination foam, like I said, it's a bubble. It's a combination of which a gas dispersed in liquid. Foams are bubbles. And out of all this now, you can see there is no one in which gas is passing through liquid. So for me, if I'm in the exam hall in this type of situation, the only thing I'll pick this one, because this is the only one that has a dispersed phase. are dispersed medium of liquid. Others are having dispersed medium of gas. So, and the dispersed phase should be what? A gas dispersed. So I will take what? Emulsion. Because this aerosols is what? Liquid dispersed in gas. It is what? Solid aerosols and what? Solid dispersed in gas. It is solid and liquid. It can be solid and liquid aerosols. So just write these tiny notes down. And I think so. So for me, there is no option here. I will not pick answer. And that is why I said I want to explain better. So, but I am very sure it's a typo. When next you see them, keep this thing in mind. It will really help you to solve questions on them. So I've done 20 questions. I will end this class now. Sit down, read your notes. The remaining 20, we are going to do it and talk about other things that is related to them. So I will see you next class. You have a wonderful night. Good night and enjoy yourself.